Hello everyone, my name is Zhou. It's my honor to share our work with you. The title of our paper is Follow-up test cases are better than source test cases in metamorphic testing, a preliminary study. I will introduce the paper from the following 5 aspects: introduction, experimental design, implementation, experimental results, and conclusion. Metamorphic testing is a technique for both test case generation and test result verification. It has been demonstrated by various studies to be an effective method to alleviate the oracle problem. It makes use of some relations among multiple and related inputs, as well as their corresponding outputs, to provide a test result verification mechanism, alternative to the oracle. We do not care about the actual outputs of the target programs, but we would like to know whether the outputs of source test cases and corresponding follow-up test cases violate metamorphic relations. The focus is different when we use metamorphic testing to augment the test datasets for DNN classifier systems. We use metamorphic relations that have the same labels for their source and follow-up test cases. Since all source test cases are labeled, we can therefore assign the corresponding labels to all follow-up test cases. Recently, some researchers have found that with the same size, the augmented test dataset usually have higher fault detection capabilities than the test dataset which is not augmented by metamorphic relations. The augmented test dataset consists of source test cases and follow-up test cases. Source test cases is randomly selected from original test dataset, which means they won't contribute to the improvement of augmented test dataset. Follow-up test cases are constructed from metamorphic relations and source test cases. They should possess part of the useful information embedded in the source test cases and metamorphic relations. So, it is natural to ask whether the improvement of fault detection effectiveness is mainly contributed by the follow-up test cases. Based on this research question, we have designed our experiment. Our experiment is based on the net models which contains the net 1, the net 4, and the net 5. The dataset used here is MINIST. MINIST is a dataset widely used as a common evaluation set for image classification. All the digits in MINIST are size normalized and centered in the image. We have designed 6 metamorphic relations to conduct our experiments, and all the metamorphic relations are designed not to change the label, and all of them are one-to-many metamorphic relations, which means one source test case can generate more than one follow-up test cases. We use FDE as our evaluation matrix. It is defined as the ratio of the number of incorrectly classified samples to the total number of samples. Intuitively speaking, the more samples are misclassified, the larger FDE are, and hence the higher fault detection capabilities are. Thus, we can compare the fault detection capabilities of 2 test datasets by comparing corresponding FDE. Here is our experimental setting. We conduct our experiments on 5 different sites, with varying the percentages of follow-up test cases. Here is the implementation of our experiment. We first use MINIST data to train the models, and then we randomly select the samples from the test dataset of MINIST as source test cases. We use these source test cases and design the metamorphic relations to generate follow-up test cases. And then we can construct augmented test dataset. Finally, we use the augmented test dataset to test the model and get the FDE. Here are my experiment results. The three figures show the FDE of the augmented test datasets constructed by different metamorphic relations on different models. And the percentages of follow-up test cases are all set to equal. As observed, the FDE of different metamorphic relations are all higher than the FDE of no MR, which is represented by the orange color. No MR means the test dataset only contains source test cases. So we can conclude that follow-up test cases have higher fault detection capabilities than source test cases. Here are our second conclusion. We have conducted the experiment on investigate the impact of the test dataset size on FDE. Part of the experimental results are shown in the figure. As we can see, the lines of all metamorphic relations on the three models are basically a horizontal straight line. That is, the values of FDE remain unchanged despite the increase in the test dataset size. In other words, the size of the test dataset does not affect the views of FDE. Also, we have studied whether the percentage of follow-up test cases will affect FDE, as observed when the percentage equals 0, which means the test dataset only contains source test cases. The FDE is the smallest. As the percentage increases, the FDE increases, implying higher fault detection capabilities. So we can conclude that the FDE of the test dataset are proportional to the percentage of follow-up test cases. Here is the contributions of our paper. We have conducted experiments to investigate whether the fault detection capabilities of follow-up test cases are better than source test cases. The FDEs of the test dataset are related to the percentages of follow-up test cases and metamorphic relations, but not the size of the test dataset. The FDEs of the test dataset augmented by some metamorphic relations are larger than those augmented by other metamorphic relations. But this needs a more comprehensive study in the future. And this is all of my report. Thank you.
Okay, thank you very much for the talk. So now let's come to the question and answer session. We have two questions from the chat page. So I'll read them and you answer these questions just one by one. The first one is a question from Sergio. He said, it seems that your results are mostly based on the fault detection ratio, that is FDE in your paper. So have you considered using any forms of coverage adequacy criteria like neuron coverage?
Okay, I will answer this question. In fact, using the coverage adequacy criteria is the next step of our future work. Because as we all know, the fault detection ratio, which is FDE in my paper, is a more intuitively result. It equals 1 minus the accuracy, which means it depends on the accuracy. And the accuracy is a more reliable result. So we want to study the result on FDE, which means the result on accuracy, which will provide a support for our future work. Because accuracy is a more reliable, intuitively speaking, than the coverage adequacy criteria. So maybe we will use the result of this paper to study the coverage adequacy criteria.
Okay, so you finished?
Yes.
Okay, thank you very much. So we have another question from Melvin. So could this not simply imply that the source test wasn't a very good, like not very diverse? Could be a possible reason.
Yes, I think so. You know, the DNN model is very different from the conventional software. It rely on the training data. The source test dataset is all selected from the test dataset, which is belong to the same distribution with the training dataset. That can tell us why the DNN model always have a better performance on the test dataset. But when we use metamorphic relation to generate a new test case, which is the follow-up test cases in my paper, and the result was not good as the source test cases. That's because the metamorphic relation can change the distribution of the source test case, which means the distribution of the follow-up test cases is different from the original distribution. I think that's the knowledge embedded in the metamorphic relation, which cause such a difference. And I finished my answer.
Okay, thank you. I think actually you can, these two questions collectively can give you maybe some inspiration, because
yes,
the title of the paper is why the follow-up test case is good, is better, and at least for me, I didn't really get the reason that why the follow-up test case is really good, is better from the paper. But from your explanation, I have some idea about the reason. So just like what you said, it could be a conjecture or hypothesis that the follow-up test case could be more diverse, and the source test case is maybe because they're created as a benchmark, has been well used, or whatever. We just don't know. We just don't know. So maybe you can consider to try to evaluate or try to measure the coverage adequacy within the source test case and as well as within the follow-up test case, and to compare the difference and to tell why the follow-up is better than the source. Is because I'm also curious about the second question. So why the follow-up is better? Is it because that the source is not diverse enough? Is it because that you generate follow-up test cases which are more diverse? I have this question actually. So maybe you can consider to use the coverage criteria suggested by Sergio, and to try to compare these two test sets, and to investigate about the reason why the follow-up one is better.
Yes, thanks for your suggestion. The problem of the title is also pointed out by the reviewers. So we changed our title to the follow-up test cases are better than source test cases or preliminary study.
Okay.
Yes. And I think the suggestion of the first question is also very good, and that is our next step of our future work. As I said before, the FDE is a fundamental metrics of this work, because it is more reliable, because it relies on the accuracy. And the coverage adequacy criteria is more high level metrics, and I will try to add it in our work in the future. And thanks for his suggestion. And the second question, I think the follow-up test cases are better than source cases, is because the follow-up test cases process part of the information of source test cases, and it also process the information embedded in the metamorphic relation, which as I said before, the source test cases have a similar distribution with the training dataset, and the DNA model trained to class assign each or correct label. But the follow-up test cases, the distribution has changed by the metamorphic relation, so it have a higher fault detection effectiveness, I think. And I will do more experiments to support my my worth, I think.
Okay. Okay, thank you very much. So I have another question. So you have 6 MRs. Actually,
yes.
You have 6 MRs, but why MR2 is so outstanding? Have you ever expect the reason? MR2
yes,
is so outstanding.
Yes, I have mentioned it in my paper, but just one sentence, because the dataset is the minist, and it is all size normalized and centered in the image, and the MR2 is all is try to shift the image from the center, which means the knowledge embedded in this metamorphic relation is never existent, exist in the original dataset. I think that's why his performance is so good.
Okay, thank you. Another question about your figure 1. You have no MR. Maybe you use no MR as a reference, right? But why is this FDE for no MR start from 0 or start from a value slightly larger than 0?
Figure 1. Oh.
Is it from 0? Because
no, it starts from, on the right of the figure, it has a number, and it is a view of no MR.
So if you don't use any MR, you can only check a very small amount of problem. But if you use use MR, you can check much more problems. Is that your